and welcome back. This will finish up our review, and we will be looking at graphs, lines, and just a little bit more. So to begin with, looking at graphs of straight lines, we have y is equal to 3x minus 2, and this is something that you've probably seen quite a bit before. But if we say plug in a 0 for x, we'll get 3 times 0 minus 2 should be minus 2. So the point x is equal to 0, y is equal to minus 2 will be along this line. If we plug a 1 in for x, 3 times 1 minus 2 would be 1. So then the point 1, 1 will be here. And if we were to plot a bunch more points, we might be able to convince ourselves that this is going to be a straight line. The way that we can describe a straight line, we'll just have to pretend like that's straight, as good as I can draw. So we can talk about the slope of a line, and the slope is going to correspond to the incline here. So since our line is going up and to the right, we'll think that this is going to be some sort of positive incline, and because it's quite steep, it should be fairly large. So how do we actually calculate slope? So slope has the following formula. If you take 2 points along a line, x1, y1, and x2, y2, so for example, maybe our 2 points could be 1, 1, and 0, negative 2, what we do is we subtract, we look at the difference in the y values, and we'll divide that by the difference in the x values. So the difference in the y values is how far we've come up, and the difference in the x values is how far we've gone over. So rise versus run. Rise meaning going up and down, and run meaning how far have we gone over, say, left and right. So let's come up here and calculate the slope for this line. Our 2 points will be 1, 1, and 0, negative 2. So for the y values, I'll take 1 for this top one, and I'll subtract the bottom one. And then for the other one, I'll take, again, the x value minus the other x value, and we'll get 3 divided by 1. So one way to interpret this is if we go over 1, so the run is 1, so if we go over 1, we go up 3. So over 1, up 3. So our slope is going to be 3. This is fairly straightforward in this sense. You just take 2 points along the line, and we can calculate the slope. The other thing that we want to do is identify the y-intercept. So this is the y-coordinate at which the line intersects the y-axis. So again, we have our x-axis and our y-axis, the vertical axis, and we hit the y-axis at negative 2. So for the y-intercept, we normally use b, and this is going to be negative 2. And then right away we can begin to see some patterns. We've got 3 and negative 2, and we also have 3 and negative 2. And this is not a coincidence. This is actually a very nice way to describe the equation of a line. So for the slope-intercept form, we have y is equal to mx plus b. So if we see an equation written as y is equal to mx plus b, we know that this is going to be a straight line, and we can read off the slope and the y-intercept. Let's check and make sure that we understand exactly what's going on. The slope of the line, maybe I'll do this, is going to be y2 minus y1 over x2 minus x1. So the y value we get by plugging in the x value. So we know what y2 is going to be if we know what x2 is. If I plug in x2 into here, y2 is going to be m times x2 plus b. Also, if I plug in x1 into here, I'll have m times x1 plus b. And then I want to subtract these and then subtract the bottom. So again, if I plug in x2 into here, I'll just get y2 is going to be equal to m times x2 plus b. Likewise, if I plug in an x1 in there, I'll get m times x1 plus b will be the y1. So these are why we have these two values on top. And if we simplify this, we'll get mx2 plus b minus mx1 minus b, distributing that negative sign over x2 minus x1. And then plus b and minus b cancel. I've got m times x2 minus m times x1 over x2 minus x1. And then I can factor out an m. And we'll see that everything works pretty much how we should, how we think it should. The x2 minus x1, x2 minus x1, and we're left with an m. So the slope in this equation is just m. The y-intercept is a little bit easier to figure out. If we think about where should the y-intercept be, well, it's along the y-axis. And along the y-axis, this is where x is equal to 0, because we're not to the right and we're not to the left. We're right in the middle, which is where x is equal to 0. So if I plug in x is equal to 0, y would be equal to m times 0 plus b, which means y is just going to be equal to b. So b is going to be the y value when x is 0. Hey, this makes sense. M is the slope, b is the y-intercept. Now, given an equation, it might not be in slope-intercept form, so we can put it in there. Again, the main characteristic here is that we have y is equal to something times x plus a little bit extra. So the point here is that we want to get y by itself. So let's subtract 3x from both sides to get 6y is going to be equal to minus 3x plus 12. And then I'll divide both sides by 6 to get y will be equal to 3 divided by 6 is a half. So this is negative a half x plus 2. And then we can use this information to graph our function, our equation here. So let's go this. Our y-intercept is going to be 2. So we know that this line passes through the y-axis at the point y is equal to 2. And our slope is negative 1/2. So negative 1/2, the negative means that our line is going to be going down as it goes to the right. How fast? It's going to go down 1 every time we go over 2. So again, rise over run. We can think of this as being negative 1 over 2. So we're going to go down 1 every time we go over 2. Down 1 over 2. If we're coming from over here, it would be down 1 over 2 would land us right there. So we have our straight line coming down just like that. So graphing these are quite simple when we can identify what m is, what our slope is, and what b is, our y-intercept. There is another way to write the equation of a line. Another really nice way is point slope form. And in point slope form, we have y minus y naught is equal to m times x minus x naught. Again, we use an m because this is going to be the slope line, and x naught and y naught is going to be any point on the line, and this is quite nice. So let's just use this formula to find the equation of a line passing through the origin with slope 1. So first of all, we have to find a point on the line. Well, it passes right through the origin. And the origin is just another name for the point 0, 0. And the slope 1, so this is going to be m is equal to 1. So if I plug everything into our equation, we'll have y minus our y coordinate, which is 0. It's going to be equal to m, which is 1, times x minus the x coordinate of our point, which is 0. And all this simplifies down to y is equal to x. and that's about it. One thing to notice is that if you choose the y-intercept for point slope form, what does the y-intercept look like? Well, the y-intercept is always going to be a point along the y-axis. So the x value is 0, and the y value we call b. So if we have slope m, and this, if we plug this into our equation up here, we'll have y minus b is going to be equal to m times x minus 0. And if you simplify this, this becomes y is equal to mx plus b. So these are essentially the same equations for the same sorts of lines, the same information in there. This one is slightly more general, and we get y is equal to mx plus b if we use the y-intercept as the point along the line. So all that is well and good. There are a few special cases that we really want to consider. So with a horizontal line, we can imagine that we have our line like this, and maybe we come across. So the question is, what's going on here? What's the slope? What's the line? Well, it's pretty easy to calculate the slope. If we choose any 2 points along a horizontal line, we can see that the x value may change, but the y value doesn't. The height is always just going to be always going to be the same. So when we look at the slope being the difference in the y values, so y2 minus y1 over x2 minus x1, if they have the same height, y2 and y1 are in fact exactly the same. So if you take a number and you subtract it from itself, you get 0, and 0 divided by anything is 0. So a horizontal line will have slope 0. And that makes the equation of our line fairly nice. Our line is just going to be y is equal to b, where b here is going to be the y-intercept. So we can graph lines like y is equal to 1, y is equal to negative 13, y is equal to whatever, and we know that the height never changes because it's constant. So this is going to be a horizontal line. And likewise, we can look at vertical lines as well. So with vertical lines, we have to be a little bit more careful because some things will go wrong, but we'll be able to deal with it. So let's say that we have a vertical line over here. And again, what I can do is we can try to calculate the slope by taking 2 points along here. We'll have an x1, y1 and an x2, y2. And what we'll notice is that if we have a vertical line, the x values aren't going to change. So if we have the two same x values here, a number minus itself is always going to be 0, right? But we can't divide by 0. So for a vertical line, we say that the slope is undefined. And because the slope is undefined, we can't define an m. Y is equal to mx plus b doesn't really apply. There is no m. However, we can still describe this line. We just want to say x is equal to a. And a is going to be the x-intercept in this time. And why is this? Well, we're going to fix a position on the horizontal axis, and our line goes straight up and down. So we can have any height we want. There's no restrictions on y, but x always has to be the same thing. So this is just the equation for a vertical line. For a horizontal line, it was y is equal to b. and that's enough for about straight lines.